All right, I guess we'll get started. Welcome to session 4. And in this session, we're going to pick up where we left off with user input. We're going to basically be centered around the Rotary Encoder and how we can interface that with the ESP32 and use it to actually as an interface to change frequency. So if we get through all the samples today, at the end we'll actually have a very rudimentary VFO with a display and a tuning knob and a band selection. So we'll start out with our session here. So our goals for this session is basically learn how to interface with a rotary encoder, and we're going to be using a particular library called the AI ESP32 Rotary Encoder library. It's very straightforward, very simple. And then we're going to take what we've went through the last couple of sessions with the SI5351 calibration, the OLED display, and this rotary encoder, and start putting together the basis of a SI5351 VFO. So we'll start talking first about what a rotary encoder is. So according to Wikipedia, a rotary encoder it's also called a shaft encoder. It's basically an electromechanical device that converts the position of the shaft or axle to either an analog or digital output. There's two types of encoders. There's the absolute encoder, which is looking at the shaft position. So it's more like an angular transducer you've got from 0 to 360. Let me let Greg in here. The other type of encoder we have is the incremental encoder. And that's it basically increments positive or negative. So when you turn the shaft to the left, it's positive. When you turn the shaft to the right, it's a negative. So what we're working with is really an incremental encoder, so that every click of the turn, it's either it adds one or reduces one from the value. So these are the pins that we're going to use. So because this is not an I2C device, we've got to set up a different serial interface to it. So we've got a clock, a data, and a switch. And we're going to use 3 other GPIO pins to interface with it. So we'll use GPIO pin 5, which is pin 10 on the J3, and then GPIO for the clock, and then GPIO 18 for the data line. And then because this has a push button switch, we'll also use GPIO 19 for the switch line. So the clock, the data, and the switch are actually outputs. And if you want a reference to the different libraries, and I also put in a tutorial from UPeasy in here that kind of walks through the basics using the library. They use a different set of pins, but since we got the I2C interface going for the SI53 and the OLED display, we basically could use any general I/O pins out. So just to kind of show you where it's at, if you look down the right side of this, you'll see GPIO 19, 18, and 5. They're all right grouped together right next to the ground there. And then I also updated our schematic to show how the connections are made. And I did correct this so that the pins for the the display are correct as well. So as you can see down in the bottom here, the bottom right, SW1 is our rotary encoder switch. And we're taking ground, goes to the ground on the ESP32, and VCC goes to our plus 3.3 volts. And then we're taking the switch line, which is the third pin, that's going to 19, and then the data line runs to GPIO 18, and then the clock runs to GPIO 5. And I guess what we'll do here, let me get my overhead view. And you guys should be able to see that. So what we're talking about are these 3 pins here. So this is GPIO 5, and I'm running that to the very last pin over here. And then the blue line coming off of this is GPIO 18, so it's going to the data line, which is the 4th pin. And then 19 is coming off, or going to the clock. And then I just piggybacked the power and the ground off of our existing one off of the OLED display.